Hello everyone, it's 10 o'clock sharp here in the Netherlands, so we're going to start with today's webinar. Welcome. My name is Eric Nijveld, co-founder and CEO of technologycatalog.com, the leading technology platform for the energy transition. In November last year, we announced the winners of the Tech for the Energy Transition Awards 2021. And our motivation for organizing these awards was to highlight the role of technology in achieving net zero. There were 5 award categories, and in today's webinar, we give the 5 winners, as well as the other 10 finalists, the opportunity to pitch their technology. And by the way, for those who didn't make it to the finals last year, we're going to organize another award competition this year, and more details will be announced sometime in the middle of this year. Before I move to the first category, few practicalities. For each category, we will first do the pitches of the finalists with 6 minutes per company. This is then followed by a brief Q&A session. And if you have any questions, you can type them in the Q&A box that you see on your left-hand side. And in case there's not enough time to address your question, then I would like to encourage you to contact the supplier directly. And an easy way to do that is to go to the technology page on technologycatalog.com and to type in your question via the contact form. The webinar will be recorded and you will receive a link after the webinar, and feel free to share the link with your colleagues. Let's move to safety, the 4th theme of the award that we organized last year. Safety, it's a theme that forever will be relevant, as it's always priorities for companies in practically all industries, not just in conventional industries. The same applies for renewables. For example, for hydrogen to take off, it's just key to operate safely and to protect people, as well as to keep your license to operate. So for that reason, we included safety in the competition. With that, we'd like to move to the first speaker from Distran, also the winner of this category, and a company based in Switzerland. And with that, I would like to hand over to Anna Gutierrez Gonzalez. Over to you, Anna.
Yeah, good morning, everyone. First of all, I'd like to thank Technology Catalog for considering our ultrasound camera as a top technology in the safety category, and also for allowing me presenting you today a new safe, fast, and reliable gas leak detection method, which are ultrasound cameras like the one you can see on this slide. Next slide. First of all, so why looking for leaks? Actually, for many reasons, including reliability, efficiency, to control environmental emissions. However, today we want to focus into the safety aspect. And regarding safety, accidents due to leaks can happen in many industries, including, next slide. So in the oil and gas field, for example, where they work with methane and hydrogen, two flammable gases that can lead to explosions if they leak. In power plants, where they also work with hydrogen, hydrocarbons, and other gases such as superheated steam, which can cause important injuries on workers, or in chemical plants, where people handle other potentially hazardous gases that can present a safety hazard if they leak. However, traditional leak detection methods are either slow, not versatile, tedious, or even difficult to be used by operators in the field. Next. For this reason, and as an alternative, today at Distran we develop handheld ultrasound cameras for remote gas leak detection. So with just the device that you can see on this slide, we can detect leaks from any type of gas, including vacuum leaks, from a distance of up to 100 meters. Now let me show you how this works. Next slide. Gas leaks are known to emit ultrasounds as the result of the flow turbulences that are generated at the vortices of the expansion. And an ultrasound camera picks up these sounds with the 124 microphones that it has all displayed on the red front panel that you can see. Basically, by measuring the time differences that it takes for the sound wave to reach each individual microphone, the camera is able to reconstruct the exact leak location. And then it does overlay this acoustic information with the optical video image, resulting in a result like the one we can see on the next slide, where we should have a video. So can we please play the video? So use a slide. Yeah, here. So this is a natural gas leak detected in a pressure reducing station from up to 30 meters. And here we can see how we went closer to the leak to exactly verify the leak location. So as you can see, with the ultrasound camera, any operator, even without a lot of experience, can really see leaks from a distance. Moreover, the camera quantifies in real time the leak rate, so the amount of gas that is escaping from the leak, as you can see on the green rectangle on the bottom. Next slide. So now I just like to show you some of the sectors that are at the moment using our camera. So we have customers in the oil and gas field, from upstream using detecting leaks in offshore rigs to downstream in refineries and petrochemical plants, or in midstream detecting natural gas leaks in compressor and pressure reducing stations, or even LNG leaks. Next. As well, we have the camera used in power plants, where they use it to detect steam, methane, or air leaks in very challenging situations, like the example we see on the slide for this air leak detected inside the enclosure of the steam turbine from a distance of 15 meters, so in a very noisy area. And next slide. In chemical plants, where the device is well suited because it can detect leaks from any type of gas, including the acetylene leak that we can see, nitrogen leak, or even, as I mentioned before, vacuum leaks. Next. Yeah, so to conclude, basically, ultrasound cameras are a novel technology latest with the, in line with the latest requirements. They just increase the quality of surveillance. So basically, they allow us to locate leaks faster than any other method from a safe distance in potentially explosive areas, as if the device is ATEX certified, and also in unexpected locations, leaks that we would probably miss with other methods. Moreover, it can quantify the leak rates in real time based on specific gas models, and it offers digital reporting to favor the traceability when documenting findings. Next and last slide. So the Ultra Pro is even though it's a new technology, is proven and established and is nowadays used by industrial leaders around the world, like the ones you can see on the slide, such as Total, Shell, BASF, or even the NASA. And with this short presentation, I hope I have given you a slight overview of what you can do with an ultrasound camera. And if this has triggered your interest, please don't hesitate to have a look at our website and contact us. We'd love to hear from you. Thanks for your attention.
Many thanks, Anna, and also thanks for including that video. That was very powerful. I actually hadn't seen it myself, so it was great to see. Thanks for that.
Thank you.
So with that, we move to the next presentation from Qlayers, and the presentation will be done by Christopher Schneider. Christopher, over to you.
I will present Qlayers today to you. Our company was founded in 2017 with the goal to make coating robots for various industrial surfaces. At the moment, coating is usually done by hand, which you can see on the next slide. This is a lot of problems. As you can see here, people are usually working at heights. They also get in touch with the hazardous paint chemicals. Especially when rolling is done, it is a very slow process. And generally because of the human error involved, the quality is inconsistent. It depends a lot on the experience of the worker and also whether they have a good or a bad day. And in the end, it also results in a lot of paint waste. So on the next slide, you can see the technology we came up with. First, looking at the regular spraying, another big problem is, as you can see, overspray. In practice, we see that usually 30%, sometimes even more, up to 50% of the paint is just wasted because of overspray, meaning the paint particles simply go to the environment and therefore are a hazard for workers and the environment itself. So what we have is a special shielding system. So on the one side, we chose a print nozzle, which makes sure we have a transfer efficiency of 90%. That means that at least 90% of the paint is actually landing on the surface, and the 10% that don't land on the surface are sucked up by a suction system. And that way it is made sure that basically no particles are escaping. This is also supported by the hood, which you can see here, which is surrounding the spray nozzle. And that way, yeah, we can make the process safer. So we took this technology, and as you can see on the next slide, we put it on a robotic crawler. This crawler we developed for storage tanks. So there's a crawler with the hood on the side of it. This controlled using the remote controls you can see on the left side. And the rest of the paint system is included in a trailer, which you can see on the bottom left. The trailer basically includes everything that's necessary, such as the pumps and the software. And from there, then the hoses go to the crawler. On the right side, you can see the setup. So basically, you only need two things to connect, which is electricity and compressed air, and of course the paint. And from there onwards, you connect everything to the crawler. The crawler itself is magnetic, put on the tank, and in addition secured using fall arresters. And then it's driving along the tank vertically from the right to the left, and that way coat the tank all around. On the next slide, you can see a comparison between the manual and the robotic process. And as said before, especially the precision is a big advantage of the robot, since we can control factors like the paint flow and also the speed of the robot. We can make sure to have a consistent layer thickness on every position of the tank. That way we can also predict degradation and maintenance better. It is also safer, since for the parts which the robot can cover, we don't need people working at heights. And it is drastically faster, especially when comparing it to the rolling process. We can see that the robot is going the speed of around 6 workers. And in the end, it is, as said already, also more environmentally friendly, because on the one side, paint waste is reduced, and on the other side, also the paint particles that are not landing on the surface are collected, and that way they are no hazard to the environment itself. On the next slide, you can see the videos of the robot in action. So here's the tank queue for storage tanks. And we also developed a robotic arm, which you can see in the middle, for wind turbine blades. What is special about the robotic arm is that it is also able to code more complex structures and smaller structures. So we saw, especially with wind turbine blades, that a crawler doesn't work properly, also because of the material, which is not magnetic. And generally, we also tested our crawler last year in September on ships, because we saw, especially on large flat surfaces, as the one you can see here, the robot works quite well. And you can also make the process a lot safer and better for the workers and the environment. And yeah, on the last slide, you can see our contact details. So if you're interested to learn more, feel free to take a look at our website, Qlayers.com. And also feel free, of course, to reach out to us. And yeah, if you have questions, you can also ask them in the Q&A session afterwards.
Many thanks, Christopher. We're now going to go to the third presentation. And after the third presentation, we do Q&A. So for those of you that who just joined, you can type in your question in the Q&A box. So for the last presentation, we go to Nuventura, a company based in Germany. And the presenter is Nicholas Ottersbach. Nicholas, over to you.
Hello, hi, good morning. Can everyone hear me?
Yes, loud and clear.
Perfect. Right, so yeah, my name is Nicholas and I'm part of the business development team at Nuventura. And our goal at Nuventura is to make the use of SF6 or sulfur hexafluoride obsolete in the energy industry. Now, you may be asking yourself what SF6 is, and the answer to that is on the next slide. Yeah, great. So SF6 is actually the world's strongest greenhouse gas. 1 kilogram of SF6 is equivalent to around 23,500 kilograms of CO2. And the annual emissions of this gas are equivalent to the yearly CO2 emissions produced by around 100 million cars. So its contribution to climate change is not insignificant, and its current concentrations in the atmosphere are actually at the highest they've ever been. And the use of this greenhouse gas is actually expected in a business as usual scenario to grow by around 75% by 2030 from 2019 levels. And the reason for this extreme growth can be found in the next slide. Right, so yes, so the reason for the significant growth is because of its use in something called gas insulated switchgear. Now, all you really need to know about switchgear is that they are very important components that can be found within all electricity grids and electrical infrastructure. And their function is very much similar to fuse boxes that we have in our homes, but of course at grid scale. So their job is to isolate and protect different nodes in the grid. So yeah, so switchgear can be found throughout electrical infrastructure, from wind turbines to substations to these anonymous looking switching houses that you often see at street level. Next slide, please. Right, and because of this pretty strong impact on the environment, SF6 is attracting more and more attention from regulators around the world, predominantly the European Commission and also the California Air Resources Board in the United States. They're both expected to call for the phasing out of SF6 in the energy industry by 2025. And more recently as well, the Chinese government has also created a working group that is focused on evaluating the use of SF6 and also potential replacements for this gas in the Chinese electrical infrastructure. So because of the environmental impact and the regulatory oversight that is becoming more and more active, we need sustainable alternatives to SF6 using GIS, and that's where Nuventura comes in. So next slide, please. Right, so we've developed a medium voltage gas insulated switchgear, which replaces the SF6 with dry air. So that's essentially just normal breathable air, but with the moisture sucked out. And we've achieved this whilst maintaining all the benefits that make SF6 GIS attractive around the world, namely compact physical dimensions and also high reliability. Next slide, please. So in terms of what we've achieved so far with this technology, the whole process started in 2016. In 2018, we had a pilot with the Westnets, and then we had the technology type test that was certified according to European standards, and we had our first manufacturing client due at ADE in 2020, and this was followed by a couple of pilots, one with Ionidis and another with Apex, a hydrogen solutions company. And in the coming months, we're going to commission another pilot in Spain, Austria, and also have a second client, a manufacturing client in Turkey. So yes, I think that is the final slide. Thank you very much.
Thank you very much, Nicholas. And I have to admit, before your submission was made for the awards, I had heard of SF6, but I didn't realize it had so much impact. So thanks for also highlighting that during today's presentation. So we have a couple of questions coming in, and also one generic question. Let me start with that one. Would it be possible to get an email sent with all the names of the speakers of today, So what we'll do is, following this webinar, is that we share the recording, and we also share indeed the names of the presenters, so people can reach out to the presenters directly and follow up. And as also indicated earlier, one other way to reach out to the companies is via the relevant page on technologycatalog.com. So you can go to the platform and search for the technology. Let me start with a question to Anna. What is the detection distance limit of the ultrasonic camera?
Yes, so we can detect in principle leaks up to 100 meters from the leak, but it depends how big the leak is, because the sound emitted by the leak will get attenuated with the distance. So the smallest leak that we have detected, it was a methane leak, about 0.3 liters per hour, detected at 30 centimeters. If we go further, for example, this leak, we could probably detect it from 1 meter, if it would be a 1 liter per hour leak or something like that. This is in very good quiet conditions. In industrial conditions, we usually expect to detect leaks between 2 to 5 liters per hour at 1 meter.
Okay, and let's do one other question to you. Can the camera be integrated into a autonomous or remotely operated vehicle, a drone, to reduce human exposure?
Yeah, so I think we have some projects with the goal of integrating the ultrasound camera on crawlers or robots, I think as well on drones. It's not really the main application of the camera at the moment, but we do consider it, and one could perfectly envision that.
Yeah, thanks for that. Building on the theme of integration, a question to Qlayers. Could Qlayers integrate additional technologies, for example, for still condition inspection?
Yeah, generally that's possible. The reason why we only focused on coating now is because we saw that there's already a lot of solutions available, both on, for example, also surface preparation. If you're talking about blasting, there's a lot of demand, but also on inspection. There's different devices available, but if we see that there is demand for this, it is definitely also possible to look into a further implementation of such features.
So if anyone in the audience is interested in this, please reach out to the company. And indeed, great to hear that in principle it's possible. So thanks for that. Then a question to Nicholas. So with all the focus on CO2, does that help you or hurt you to an extent?
Right. I mean, yes, of course, CO2 in terms of climate change is the main focus, as it should be. But yeah, I think it's often forgotten that there are other greenhouse gases apart from CO2. I mean, methane is the other kind of more mainstream gas. But yeah, there's a lot of gases that are being used in industry applications which don't really have a mainstream kind of there's no real kind of understanding about what's in these technologies, such as SF6. Now we see more and more as the topic of climate change becomes more and more kind of prevalent. Yeah, there's attention is being kind of drawn away from CO2 to these other greenhouse gases such as SF6. So yeah, in terms of the climate change debate, I think it's becoming more and more part of it. But of course, CO2 is by far the biggest problem in terms of climate change. So we think that's kind of natural, and yeah.
Yeah, thanks for that. There's one question coming in, actually a question I'm happy to handle. Coating materials, is that renewable? Actually, what we do, not just with the award competition, but also with this, with the platform in general, is to include technologies that are, say, pure renewables technologies, but also technologies that can enable renewables. And the reason why we included safety in the award competition is that, yes, safety is just critical. If your operations are not safe, yeah, you run the risk of losing your license to operate. Hydrogen, for example, is fantastic, but if there would be a couple of major incidents in hydrogen plants, then the public acceptance for hydrogen would disappear, and the same goes for other renewable sectors. So therefore, safety and also maintenance, which will be covered in the next category are therefore, in our opinion, key to make sure that we put focus on those, and also because it's a lot of cost is involved in it. And if there are opportunities to operate safely, maintain safely, and do that cost effectively, it does help renewables projects. So that a bit of background. It's indirect, we realize that, but still important to make sure that renewables takes off. So I hope I've clarified that point, and we'll also continue to clarify that for the global platform. So there's a question for Nicholas. What's the maximum voltage of switch gears with dry air?
So our switchgear goes up to 36 kV. And yeah, I think we're the only provider of switchgear that uses dry air up to 36 kV. There's competition which have reached lower voltage levels or replaced SF6 with another greenhouse gas. But so far, we're the only ones that reach 36 kV and also use dry air.
Okay, yeah, excellent. And also another question for Anna, for Distran. How can the ultrasound camera detect leaks in noisy environments?
Yes, so basically the ultrasound camera, it filters out all the noises that are not emitting at the detection frequency. Moreover, when we usually talk about noisy environments, are usually areas with compressors or any other rotating equipment, and these areas are very noisy for us as humans, like in the audible region, but the camera measures in the ultrasounds, and the ultrasounds is usually a little bit more quiet. In any case, with our Ultra Pro camera, one can change the detection frequency if it's not well suited in the particular environment where we are detecting.
Yeah, excellent. And another question to you: how can you quantify the leak rates in real time?
Yes, so what the camera does is to basically convert from the sound pressure level, the sound level, into volumetric leak rate, like in liters per hour. So for that, what we have are models that take into account, for example, the distance to the leak. So the camera estimates the distance to the detected leak that we have in front of us. And then we just have to select the type of gas that we are detecting and the pressure at which this gas is on the asset that is leaking, and the camera applies the specific gas model to convert from sound into leak rate.
Yeah, excellent. Thanks for that. Hey, we have a couple of minutes left before we move to the next category. Any concluding remarks from any one of you, starting with Nicholas?
Essentially, just one thing that that comes up often when talking about renewables is, of course, renewables are essential for meeting the climate transition and fulfilling kind of reducing emissions. But we should also keep in mind that the infrastructure used to distribute this green energy should also be green, which is often overlooked. So I think this is something that we should stress a little bit more, including, of course, switchgear.
Yeah, excellent. Thanks. Christopher?
Yeah, a small point that I would add is I think an important point that's also often not looked at, especially in the coating industry, it's often looked at cost, of course, and also at speed. I think here in Europe, it's more there's more awareness, for example, of environmental protection, such as the paint chemicals going to the environment. But we also see in other regions that that's not the case, and I think that's also an important point where kind of a shift in a mindset should still happen. To say it's not only about being fast, but also being able to do it in a safe way and in a way that workers are protected and the environment is protected, and put a bigger emphasis on that. I think that's very important. That's also the way we want to go with our equipment.
Thanks for that. Hey, and I can certainly relate to all the things you said. Actually, before starting technologycatalog.com, I was at Shell for many years in the last role as technology deployment manager and running what we called a technology replication thrust for production excellence. And coating, that was clearly an area where a lot of impact could be made, cost-wise, safety-wise, but also indeed for the uptime. It touched on many elements, and certainly many thanks for highlighting the various elements during your talk and also when addressing the questions. Definitely the same goes for gas leak detection. So any final remarks from your side, Anna?
Yeah, so basically the ultrasound camera that I presented today is quite of a versatile tool. So I'd like just to encourage any interested participant to check on our LinkedIn or website, because there we try to post regularly some case studies and some customer experiences with some important leak findings. So probably there they will be able to also know more about any specific application that could be interesting.
Yeah, excellent. So many thanks to all three of you for this talk, and this concludes the fourth part of the webinar. And today, so 15 great presentations, and also thanks to all the attendees. And hopefully you will leave this webinar with many ideas on how you can improve your performance and realize your goals with technology. And we will continue to create visibility for technologies via the platform, technologycatalog.com, such that companies can find and select the right tech to improve performance. So with that, many thanks, and I wish you all a great rest of the day.